This module will cover linked lists, a different implementation of lists. So why another kind of list? This is a summary of all the runtimes we have covered previously. We see the get and set methods execute in constant time on an array list, but inserting and removing items that aren't right at the end take linear time. A linked list is good at many things an array list isn't good at. It can add or remove elements from a known location, such as the beginning or end in constant time, but if you're trying to do something in the middle of a linked list, it's gonna take O of n time. Array lists are based on an array. They allocate one giant contiguous chunk of memory. Linked lists, on the other hand, are built on the node, a tiny little class that holds a single item and a reference to the next node in the list. This is our first hurdle. How can the class have a reference to itself, inside itself? This isn't the right metaphor. This isn't one of those Russian Matryoshka doll situations, where each doll contains a smaller doll inside itself. A linked list gets its name from linking each of these nodes together. Rather than creating a large block of memory all at once, we create a node whenever we add another item. Each node in the list holds the memory location of the list we're storing and the memory location of the next node in the list. This means we can start at the first node in the list, which we call the head, and follow the next all the way to the end, called the tail, which has a null at the next location. We're essentially creating a scavenger hunt through our computer's memory. So while an array list might look like this in memory, where the list starts at index 0 at memory location 500, index 1 at 501, and so on, a linked list with the same items could look something like this, where the first node in our list tells us the next item can be found at memory location 820, and that node tells us the next item is at location 564. We typically use a more abstract view, where the boxes represent the nodes, and arrows indicate what's stored in .next, and the labels indicate specific nodes. There are a few variations of linked lists. Nodes in linked lists can also have a reference to the previous node, like so. We call this a doubly linked list. Also, the tail of the linked list can connect to the head of the linked list. We call these circular linked lists. We'll learn to build and use these in this module.